So this is module number 6, buffer overflow attack. What are buffers? Buffers are memory storage regions that temporarily hold data while it is being transferred from one location to another. So they will hold the data while the data is being transferred from location X to location Y. A buffer overflow or a buffer overrun occurs when the volume of data exceeds the storage capacity of the memory buffer. So volume of data will exceed the storage capacity means suppose the storage capacity of memory buffer is 8 bytes but the volume of data is 10 bytes. So 2 bytes extra data is present. That's when buffer overflow will occur because it is exceeding the storage capacity of the buffer. For example, a buffer for login credentials may be designed to expect username and password inputs of 8 bytes. So if a transaction involves an input of 10 bytes, that is the volume of data is 10 bytes. This is your volume of data. That is 2 bytes more than expected. The program may write the excess data past the buffer boundary. So excess data, that is 2 bytes, will be written past the buffer boundary. Buffer overflows can affect all types of softwares. They typically result from mal-informed inputs or failures to allocate enough space for the buffer. If the transaction overrides executable code, it can cause the program to behave unpredictably and generate incorrect results, memory access error or crashes. So this is the example of a buffer overflow. In the buffer overflow, we can see that the buffer is of 8 bytes. So from 0 till 7, how many bytes are there? Total 8 bytes are there. This password is fitting, but 1 and 2 is what? It is the overflow. That means the volume of data is password 1, 2. This is your volume of data, and the capacity of the buffer is storage capacity of buffer is only 8 bytes. So this 1 and 2 is the extra 9th and 10th bit. So 2 bytes will be extra, therefore there is an overflow which is happening. Types of buffer overflow attacks, that is stack based buffer overflows, are more common and leverage stacked memory that only exists during the execution time of a function. Heap based attacks are harder to carry out and involve flooding the memory space allocated for a program beyond the memory used for current runtime operations. Now, a buffer overflow attack involves several stages. The first stage is identifying a vulnerable programmer. First is to identify a program where this buffer overflow attack can occur. It is vulnerable, that means it is very much in danger. The attacker must first identify a program vulnerable to buffer overflow attacks. So attacker, what he will do? First he will find which program is more vulnerable, which program has less security. That program he will identify which is vulnerable to buffer overflow attacks, typically by finding a program that does not properly validate the size or format of input it receives. So it does not validate the size or format of input it receives is more vulnerable to buffer overflow attack. Second stage is crafting malicious input. The attacker must then create a carefully crafted input, often referred to as an arbitrary code. So then the attacker will have a code of himself. So this arbitrary code will be there. This code will work as an input code which will be put in the programmer, which is vulnerable to the attacker, designed to exploit the vulnerability in the program. So this code will be inserted in this program which is vulnerable to the buffer overflow attacker. This input is usually designed to exceed the buffer's capacity and override other parts of the program's memory. Next is sending the malicious input. The attacker then sends the malicious input to the program either by directly interacting with the program or by tricking a user into entering the input on their behalf. Either the attacker will directly himself insert the arbitrary code into the program or will trick the user into inserting the code in his programmer on the behalf of the attacker. So either he will directly insert or he will trick the user to insert it on his behalf. Overwriting memory. If the program does not correctly validate the input size, it will try to store the input in a buffer that is not large enough to hold it. So this program, which will be made by the attacker, will be such that it will not validate the input size. Because it will not validate the input size, this will be stored in the buffer which will be created, causing access data to be returned to the adjacent memories. So now the access data is there and this program is incapable of validating the input size. Therefore, everything is now stored in the buffer. So attacker will only choose those programs which are incapable of validating the input size, causing extra data to be returned to the adjacent memory. Executing arbitrarily code. If the attacker has successfully overturned the parts of the program's memory, they can potentially set new values for the return pointer, which is the address to which the program should go next up. By changing the return pointer to point to the location where the attacker's malicious code is positioned, the attacker can alter the program's execution path and transfer control to their code. So now instead of giving the correct output or executing properly, what will happen? The pointer will be changed to the pointer where the programmer's arbitrary code is present, and thereby it will cause a error. So security error will happen. Why? Because instead of giving the correct output, it is transferring the control to the arbitrarily code made by the attacker.